Let's look at projectile motion. We want to find delta x, the total horizontal displacement. Here I have the kinematic equations. We can eliminate those equations that don't help us find delta x. Now let's see this game of catch. We record that each pass takes 0.8 seconds. The initial velocity is 3 meters per second. A, which is acceleration, is 9.81 meters per second. Now it's obvious which equation we should use. But what if we know not the acceleration but the final velocity? Then it's this equation. Now I'm going to demonstrate inertia. I start standing still, then I move myself by exerting my own force. Afterwards, I stop myself by adding another force, friction. Newton's first law of motion states that an object at rest or in motion will tend to stay that way unless an external force acts upon it. Let's look at Newton's second law. First, my sister is going to push herself on a scooter. Now I'm going to try. It seems that I have to push harder to go the same distance she does. Why? It's because I have greater mass than my sister, therefore I need a greater force to help me accelerate at the same rate my sister does. Newton's third law of motion states that when something exerts a force on something else, that object exerts an equal and opposite force on the other object. In this example, my toe pick acts on the ice first, then the ice acted on the toe pick. But if the opposite forces were equal, how come the ice looks almost unchanged, but I could get up in the air? It's because the toe pick is much smaller than the ice, so the ice has a greater impact on the toe pick. Now let's look at centripetal motion. The object feeling centripetal motion here is my whole body because the centripetal force, which is tension in this case, pulls at all parts of my body away from my axis. This is why my ponytail points outside the circle. Now let's discuss momentum. Here I am riding down at 2 meters per second. I have a mass of about 54.4 kilograms. Now let's see my sister. Whoa, I didn't know that she was the Flash. She has a mass of 20 kilograms. What velocity is she running at? Remember, momentum is mass times velocity. She is running at 5.44 meters per second. And while we were having fun moving outside, we also exerted a lot of heat because it was a hot day. I'm going to be playing the oboe, a wind instrument, with one open end. The sound waves must vibrate quickly in order for a sound to come out, so I have to make my air quick enough. There has to be at least one open end in a wind instrument for us to detect sound. There are different fundamental frequencies for instruments like the oboe than that of string instruments like a piano, because the oboe sound waves have one end with a node and one end with an antinode, while both ends of the piano's sound waves have nodes. I was surprised to learn this year that the only colors we can see directly are red, green, and blue. Other colors result from a combination of two of those colors. When we interpret an object as red, red light is reflected to our eyes, and all colors are being absorbed by the object. White results from all colors being reflected to our eyes, and black results from all colors being absorbed by the black object. In a flat mirror, the image comes from behind the mirror, same distance as myself to the mirror, and the image is virtual and upright. The image is the same size as myself.